we got to know some of the concept about the solidity, and we also understand the solidity language. So just the solidity is basically one of the language. It's same as its oriented language. So that's how like there are inheritance. There is like modifiers are there. There are variables. Like how the programming language. It's nothing. Like if you have observed, if you have knowledge, prior knowledge of any of the programming language, then you might have understand that this is nothing different in the programming aspect. The same variables, loops, the same structure. So the concepts which are there even in the C++, the same concepts are there in this solidity also. Just we are using it to make the smart contract instead of class. If we compare with Java or any of other object-oriented programming language, so here instead of class we have the contract. Instead of import or instead of include, we have the pragma, and that's how we are doing it. Then again we have the variables, we have the data types, we have the function, we have the enumeration structure. So the things are almost same as when we are comparing with other programming language. So some of the concepts which we have discussed, just I'm revising it. So we have like public, so public variable, public function, private function, private variable, external variable, external function can be there. Then constructor is there. The contract which we are creating, any of the contract, any of the program is comes as a contract. External contract is there. External contract, let's say there is one contract, then we can have the one more contract. So that can be the external contract. If in case there are two contracts, then and one contract is using the another contract, then there can be external contract, means contract apart from the initial contract. That can be the external contract. Then derived contract, as how we know the concept of inheritance, we derive the property of the parent to the child. So we have the parent contract, we can have the child contract, and child contract can derive the property of the parent contract. So we have the derived contract. Then how do we call the function? We have seen we have created the function, we have called the function, we have seen that. One more terminology is here, that is UTXO, that is unspent transaction output. In case there is a transaction output is there, that is unspent, some V is there, some ether is there. So that is the thing. So there are some concepts here. So in order to understand it, let's make a small program so that you can get it revised, that the solidity concepts. So then further today is constructor. How do we create the constructor? How do we work on it? We will cover this thing. Then we have this inheritance, abstract, interface, overloading, overriding. These things also we will cover today, the concepts in this. Then fallback function is there. Then different types of accounts are there. We will cover that, person to person contract account. Then how do we transfer the money using the smart contract, using the blockchain? So there are some different functions, we will cover them. There are transfer, there is send, there is call. So different functions are there. So we will try to cover some of the programming part today, so that it will be more easy to understand for you if it comes to the programming. So let's create a small program which I'll try to cover some of the solidity concepts. So as we know, when we are working with the solidity, we are using one of the IDE, that is online IDE, and we are using the Remix. We can use this Chrome and Remix. There is remix.ethereum.org. This is one of the online IDE which we are using. You can make it zoom from here. Yesterday we have seen this one. Anyways, what we have seen a small project. So let's start. So just I'll try to cover this some of the concepts here in this new program. Simply, once again, uh, concepts here. Some of the concepts are there. Let's say in the starting itself, like we are having this. Right here. Okay, UTXO. UTXO is just a second. So generally what happens is whenever we are working with the blockchain, as we know that every time some gas gets spent, some ether is also gets spent. Okay. So when we are doing any kind of transaction, this UTXO give us the output of the blockchain transaction, and UTXO provide us output that what is the transaction which is not get spent. Means the output of the transaction in the terms of the spend, like we can say whatever data, whatever this amount is spent ether. So that is what, and that can use as an input to the new transaction. Like let's say we have one transaction is done. I have transferred one ether to another friend. Now some amount of gas will be consumed. Some of amount of V will be consumed. So whatever the unspent output will be there, that we will receive that as a form of UTXO, whatever the unspent thing. Let's say I have given the gas as a 2 lakh. So maybe some of the gas will remain. So that will be the UTXO that can be used in the like further transaction. So that is the UTXO, that is unspent transaction output, unspent amount of Ethereum or V will be there. That's I have given as a 10V as an input to run the program, but it taken the like 7V or 8V. So 2 will be the UTXO here, and that can be used for the further transaction. So that is what. So here we are going with the programming. So simply as we know that we are using Sigma, Solidity, we are using any of the version. We were using we are using like 0.04 greater than equal to this or less than. We were using this one. We can also this way also it is fine till the one version is accepting. contract name, maybe the first, or maybe I can get this as a concept. Okay. So this is the contract. How we can create the contract? This is or in any of other programming language, how do we start the program? So this is very much required. Then again, we can have variables, as we know that we can have the state variable, we can have the local variable. Then further, we can, as we know that state variables are apart from the function. So we can have the state where this is one of the variable. This is the state variable, and state variable can be public, private. Let's say this is public variable. The variable can be private as well. So maybe it can be a private. This is where 2. This is where 1. So this is private, and these are the state variables. State variables. State variables we can use in throughout the contract. These state variables. And again, when it comes to the public and private, public is in between the other contracts also, the private within the same contract. So we have the state variable. When it comes to the constructor, as we know, there we have the other languages. As we know, we have the other programming languages. We have the constructor, it assigns the memory, allocate the memory. We can use the constructor to initialize the variables. So similarly here also we can do that. So previously like this, we used to create this function like this, and maybe it can be public kind of. Previously we used to have like this, but now we get the error that functions are not allowed because it is already as the case of the same name. So it can be the contract, sorry, constructor. So and the constructor in public. So as this is the constructor, directly by default the property is that this is the constructor. Visibility to constructor. If you are not applying, make it constructor. Okay. Visibility currently it doesn't matter, it seems. So visibility, in case if you need, you can give it. It is giving anyway, it's giving the warning, so I can give it. So that is the public constructor. By default, there is a visibility. So there is a constructor. So constructor, we understand that what is a constructor, as we know that constructor is, we can initialize some variable. Let's say we are giving the value as 10. So we can use this constructor to initialize the variable, to allocate the memory. Means at the runtime, whatever the data, whatever the things will execute, that can be given in the constructor. So we can create the constructor. Then further, if we talk about, we can create the function. As we have seen, there are 3 types of function. Sorry, 2. One is view, one is pure. View we have seen whenever we want to view any kind of means the view. Then again we have the pure function, that is for the operational. That we try it. Function. Maybe there is a function name my function. It can be the type of public. If it is view, I'm just returning it value as a type of view int, and it should return some data. Maybe I can give some var 1 equal to 50. I can return here var 1. What is happening? Type function declares a view, but in this expression, you partly modify the state. Okay, fine. let it be. I'll give the value here. Okay, so this is the function in the form of view, and the one more function, as we know, that is my function one. That can, again, the modifier can be different. I'm just giving it as a pure, and if it is pure, then it will return the mathematics, means we can do some operations here. So returns, I'm giving here u int. It can return me some operation, maybe somewhere 1 plus where 2. So some operation. This function declared as pure, but this is function read from the environment. Return. Read from the event. Okay, so as this is a function, it is returning expression type of data. That is fine. So the variable, constructor, function, then again the function can be a type of pure function, that can be view function, and it can be private, it can be public. Then again, if we go further, as I was talking about, contract, this is a contract, external contract, we have the external contract. As this contract I'm just using, I can have the another contract, let's say the contract concept one. So there can be the another contract, and if this contract is using the function of the previous one, let me try it, how we can use the how we can use this previous contract. That we create this function use concept. I'm using the previous one, and then maybe it can public, as I'm having this returns, I'm using the UN. So this is another contract, and another contract is having one of the function. Now what I want to do is I want to use the previous contract functions here. So I can use in this way. The previous one is concept. See, we can use this here. We can use in this way. We can like what we are doing is we are having already one constructor, sorry, contract, and now we want to use that here. Using the C is here, C dot this function. So member function not found visible. As that is the private one, as currently right now we can understand here, if the function is private, it can only accessible within the particular function. If it is the public, as this is the public, so it can access out of that particular contract also, as this is a property of the access. So here, this is one is the external contract, and how we are using it as this is external contract, and we are using the constructor. Constructor is used here. Constructor we are using, to access the function. Right. So external contract. And one more concept we have, that is a derived. Again, as I was telling you about the inheritance. So inheritance is here possible using the is keyword. Is keyword we are using here. Is keyword is using here for inheritance purpose. So here, let's say I'm making one more contract concept 2. So in case I want to use the parent constructor, contract, so I can use is and this concepts. So here, this is what is happening. This is happening the inheritance. This is the derived contract and this is the parent contract. So what I'm doing is I'm doing the inheritance. So here, acquiring the property of parent. This is the function. It is returning the uint. So we can try here to int. I need to give one function first, because we can't call like this function abc. I have not given any of this my func name in this contract, so I am able to use it. Whatever output, let me return it. So return a. So here we have return. So here, if you see, there are some multiple concepts. This is the derived one. This is derived contract. Here contract concept 2 is child contract and concepts is the parent. So this is how like different concepts. So if we talk about the concept, other programming language, and similarly the programming language Solidity works. So Solidity is also having all the concepts, and we can work similar manner. How do we have working with the other languages? Here also we have the variables, we have the constructor, we have the functions, we have this external contract, we have this derived contract, and and the second process, we know that it is compiling process. So it does compile. It compile. I've just marked it as an auto compile. So that's why at runtime only, I'm just getting the error. Unnamed return variable can remain unassigned. Okay. I assign some value here because I've not written anything. So you int maybe ko some variable. Some of the concepts of the variable, public, private, constructor, creating of our own function, use view, using pure. Pure is returning only the operational activities. These are the local variable because they are inside the function. These are the state variable, they are outside of the function. And we have the contract where we can use the previous contract functions. So things. So anyway, whatever the function we run, that creates a button, and we can call it. And also yesterday we have seen that whatever the functions are there, we can use them in the any of the enterprise application. Free concept. So compiling, auto compile is there. Run. We can run. As yesterday we have seen, there are environment, different environments are there. Accounts by default, these are the default accounts. And simply we can deploy. Here we go. This why. Okay. Things will be here, and here if we see the deployed contract. So here if you see, there are the buttons. So this is here. Okay. Yeah, one more thing here. As you can see, there are three contracts in this. One contract is concept, one contract is concept one contract is concept two. And when you will deploy all the contracts, here we can clear the screen. When you deploy, you can see here all the one contract is deployed. Whatever the contract you want to deploy, you can select from here. Contract one, contract two, contract three. Like we have created three contracts. One is a concept one, concept two, and concept three. So currently the concept one. So concept one is having this one. This is a concept one. Sorry. Yes. The one is concepts. Okay. So concept one is having only single function. You can see here there is a single function. One more contract, that is a concept. So we can deploy that. Okay, this is concepts. Concept one, concept two. Okay, this is the concepts. Deploy it. Deploy. You can see the function my func and where. So from where it is coming, this is the my func, and there is a variable one is there. Okay. My func that is giving 50 as it is returning this one. This is the case. And one is the concept one. Right. Concept one is also giving one of the button. It is giving one of the button where we are using that. So there is a value. Yeah, value is here. The 50. It is using here. This when I run it, I can clear it. Use concept. So here I can see the value uint. So here I am calling the particular function, the previous function. So this is called, and here I'm getting the decoded output. And then we can have the third one, that is the concept two. The concept two is this. I can re-clear it, deploy it. There is a yes. So here the thing is we are inheriting this one. We have done this as a derived. So there are two things from the one thing is ABC. ABC is from the existing contract, my func and where one, that is from the previous contract. So this is how it is working. That we have the previous contract, we have the derived contract, and we can use the functionality. My func again I have called, so I'm getting this output. So from this particular function. So this is how it works. Like we have the derived concepts like contract, we have this external contract, we have some of the concepts. So from this example, actually what I want to tell you is how the basic language goes, how the language it is. It is similarly as the other programming language, just syntaxes, some of the declarations are different, but other things are same. So this is how it works. Now again, from this, we are able to understand the concept of constructor. Concept of the constructor here. What is constructor? Let me see. So we are having the external contract, derived contract. We can call the function. How do we call the function? Just now we have seen, as we have, this is one of the function. One way is we can call the function this way. We can create the constructor instance. This is the instance. Using the instance, we can call the function. One more here, we can call directly here also, as the return type is uint. The function return type is uint. So here I'm storing the output of this function into this particular variable, and I'm returning it. So this is how we can call the function. So here some of the concepts I wanted to tell you: public, private, external, constructor, contract, external contract, derived contract, how we can call the function, and one is the UTXO. UTXO is the unspent transaction amount or output. Whatever the output is remain, we are using it, of course, for the next transaction. So here we have one concept, that is the constructor. So as we know, constructor is a special function. Of course, it is not the function because it is having the name as same name as a contract. So that's how it become the constructor, and it is optional. Of course, by default, there is a constructor. As we know about the default constructor, it is the concept is here also. We have one contract can have only one constructor. There are some facts here. So one contract can have only one constructor, and constructor code is executed once when a contract is created. As we know, this is to initialize the state, to initialize the variable, to allocate initial memory thing. So that's where it is to initiate the, it will run only once. Just a second. So, and as we see, constructor can be public, internal, like, so internal constructor, abstract. Again, one more concept is here, that is abstract. We will read it. In case no constructor defined, default constructor is present. Of course, as how we have in the other languages, we have the default constructor concept. By default, there is a constructor using which we can create the instance. So here also the default constructor is available. So Solidity presents the concept. We are initializing the variables. That's some concepts. Looks like it changed. I have created this PPT on the Windows. Probably it changed to Ubuntu. That's why the fonts have changed. Yeah. So Solidity is having the inheritance concept. It is having the abstract concept, like how we have the abstract class in Java. We have the interface concept in Java. We have the inheritance in Java or any of the other languages. We have the function overloading, overriding. So all these concepts are here also. Just let's see with the example. Before that, abstract, as we know, abstract can have unimplemented method also. We can have the implemented method as well. As we know about the inheritance, we are accessing the property of the parent into the child contract. And interface, we have the complete all unimplemented method, unimplemented function that need to be implemented into the contract. We can, like in the derived contract. So there is a difference between the abstract and interface. Abstract will have the implemented as well as unimplemented function. Both can be there. In the case of interface, all functions will be unimplemented. Means implementation of the function cannot be done inside the interface. This is the same concept as others. So interface. Okay. Interface, as we know, this is unimplemented. So of course the function cannot have the body. So if it cannot have the body, there cannot be the constructor. We will not have the variables, these things. So so there is again, we are going with this. We are creating this. We can create the new file in abstract interface example. So abstract interface. So first of all, again, the pragma, Solidity, the version 0.7.0. I'm taking. I have any contract name, that is, I'm just giving for the namesake the same name. It's not mandatory, but I'm just giving it. Okay. So one contract is created. Let's create the function. Maybe I'm creating the function f1, which is, yeah. And one more thing here, if the contract, if the contract is the interface, or if it is the abstract, then the function should be external, because of course we want to use them in the different contracts. External, because we want to use this function in the another contract. Okay, so here if you see, this is one of the example of the abstract. We have this, we have created one of this abstract contract, and we can use it here. This is, we are using. So we can use once again, if you want to compile, you can run, you can deploy. Just delete whatever the contracts you have, just deploy that. Yeah, one more thing here. As currently what I'm trying to do is here I'm trying deploying this abstract one contract. Okay, so there are two. One is the ABS enter, that is the first contract, and one more contract is use them. So the first contract is the abstract contract. So we cannot deploy it. This is one thing. I'm trying to deploy the contract. I'm getting this contract may be abstract, not implemented, an abstract parents method completely or not involved, and inherited contracts constructor correctly. So here it means that whenever we have the abstract contract, this is this one. We are talking about the first one, ABS enter. And currently in this particular program, we have two contracts. One is ABS enter, one is the use them. So abstract contract will be only compiled. It will not be deployed. So what will deploy? We will deploy this one. So deploy it. It is deployed successfully. You can see here there are two functions, F1 and F2. So F1 is here and F2 is this one. So F1 is giving the output as 100. We have implemented here. And one more, it is giving the output as 50. So this is the concept of the abstract in the contracts. Now, similarly, the concept we have is of interface, like how we have the contract as abstract. Similarly, we have the interface. So if we convert these to interface, if this is interface, then what is the problem? Interface. Yeah, interface or contract, out of both, one will work. We need to create this way. So if it is interface, then it is giving the error that function in interface cannot have the implementation. Means the difference between the abstract contract and interface. Abstract contract can have the unimplemented and implemented. Interface will have the function without implementation. If we create the implementation of the function, then it will give the error. So interface will not have the implementation. So still, if you want to create the F2, just keep it till here. Okay, so that is fine. Interface, yeah, virtual is not required here. Virtual is only for the abstract. Okay, so if you see here, instead of using the keyword of contract, what I'm using is I'm using the interface. So this is the interface having the unimplemented function. This is unimplemented function. So interface will have all the function, will have the unimplemented function. And before that, just now we have seen that abstract can have the unimplemented as well as the implemented. And you need to use the abstract keyword. Now again, as currently we have implemented only F1. To have the F2 also. So use the F2 function. This I'm creating one more function. This is F2. Override, remove this override. Here also this override. The function of this missing override keyword. This is fine. This is function pure. Okay, this is pure. So this should be again pure. We need to change it. Fine. So issue. Right. Okay. Override is missing. So here, if you see, this is the interface. What we have is we have created the unimplemented function and we can implement them into the another contract. So generally, why we use the interface? To find the uniqueness. Let's say there is a ATM machine is having one of the interface. Now interface is having the different functions like deposit, maybe withdraw, maybe the transfer. So the ATM machine will have the unimplemented function, but who will implement it? The actual user or actual bank. So in case of SBI, they will be implementing their function of deposit according to their mode. And if that is another bank, the same bank can implement the function in another manner. So implementation is in the hand of a contract creator. So this is how we use the interface. Interface is containing the unimplemented function, and we are using them into the contract. So this is what we have. Once again, if you want, we can deploy it. Again, if you will try to deploy, you can see the interface will not be deployed. What will be deployed is, it will be deployed, the contract will get deployed. So contract is getting deployed, F1 and F2 is there, F2 is giving an output, F1 is also giving an output, so that is fine. So here I just wanted to tell you about the concept of the interface and the abstract and interface. I hope the difference is understood, that abstract is having both kind of function, implemented, unimplemented. Interface is having the only unimplemented function, and they are implemented in the next. So that is one concept we got. Now interface, sorry, inheritance. Yeah, okay. Inheritance, just now as we are seeing, this is a single inheritance. We have, this is a parent and this is a child. In the previous one also we have seen the inheritance. We have one parent and we have one child. In case if you want to have a note of this program, you may note it. Now again, next, as I was talking about the inheritance, acquiring the property of the parent into the child. Here we had, this is the parent contract, this is the child contract, and I was using this function. So this is one. And now, as if we have one contract, if we have the another contract, we can have the multiple inheritance also here. So we can have this concepts and concept one. This is the multiple inheritance here is possible. Also possible, like we can use the functions of the concept one and concept here. So this is what, like we have the inheritance here in the blockchain. So here the concept, we have the solidity, inheritance, abstract, and interface. Okay. So again, we have one concept, that is function overloading and function overriding. So the concept is same, how we have the same concept in other languages, the method overloading, method overriding. Similarly, here also the concept is same. Just so that is similar concept. We have the function overloading and function overriding, that we can have the multiple functions with a different argument and we can use them. That is one of the concept of the function overloading. And one more concept, we have the function overriding. As you can see here, we are overriding multiple functions. So if let me see one example. Function example. Do not create here, create in the repository. Fine. So just pragma Solidity and version 0.0.0 we are using. Then again the contract, maybe ABC, sorry, ABCD. Okay. So here I'm just creating one function. Maybe the function is overloading. I can try. So it can be the function one. So you and here. हाँ अभी किया नहीं इसलिए मैंने भेजा नहीं आपको पेमेंट अभी आया पेमेंट आएगा दो दिन इसलिए just I'm creating one function. This is maybe it is returning something like चलो मैं कोशिश करता हूँ and there can be another function with the same name func1 and it can have this different variable uint a uint b. It is also a view type. Make it a visible public view returns uint. So the function with the same name but different arguments and returning here ABC. So here, in order to call them, we may call them from the another contract. So maybe I can have an external contract. Let's say contract XYZ is using this ABCD. Okay, and now here we want to call it. So we can call it directly this way. We can have, we need to have one function. Maybe I want to print some result. So just result here. It is a public view. I'm returning this uint. So uint. And here I can have one is I'm giving here this function one. I'm calling. I can call this another function one with a different values. Maybe I'm giving a 12 and 12. Okay, that's fine. So I'm satisfying. This is what the function overloading. Function overloading concept. Like this is, we have the same name but different arguments, and we can call them. They will produce a different result. Maybe we can return any, and we can store the value of this maybe in the uint C, and we can return it. C. Okay, fine. So this is what the concept of the function overloading. Function overloading is there, and one more thing which we have, that is overriding. So we can create one more function here, the function with the name func1 with the same argument as the parent. So func1 public view returns uint. Everything is same here, and function. That's override. Yeah. Use override. Okay, fine. So here, this is, if you can see here, this function one is having the same name and argument. Here also same name and argument. But when we will see the output should be 100, as it is overriding the previous one. Means whenever we are running this contract, then the function one, this one will override the parent function. So this is what I wanted to tell you about the concept of the function overloading and function overriding. So we may try to run them. So just deployed the ABCD. We can see here the function. Yes, as currently there are two functions, we can pass the value from here. Again, this is maybe it is 50 and comma 50. So I can see here, this is giving me the output at 100, and the previous function func1, that is already 10, so that is fine. Now when the function one, func1, okay, this is method overloading, sorry, function overloading. Both functions are same name but different argument. This is function overloading, and when we're talking about the overriding, so the child is there. This is deployed. So now I'm running. So I'm having this function. Okay, 100. Result is this one. So here, if you see, I'm calling this func1. So func1, the output I'm getting from the child one. I'm not getting the output from the parent one. So this is what is happening, is the function overriding. So this is what the concept we have, the function overloading and function overriding function in the Solidity. So how beautiful it is, how like we have in the previous languages, which you have already learned. So similar concept, but in the different language. And this is where we can make the use in the contract. I hope it is clear. The concept is clear. The function overloading and function overriding. So this is something I wanted to tell about. So one more important terminology here we have is the count. This is due to the change of Windows to Ubuntu. So once we are done with the function, we are creating the function. Now, when we are working with the Ethereum, we are working with the blockchain, we have the different types of account. One is the person account. You can create, I can create, and we can get the account where we do the transfer. The transfer is of type of wallet. Of course, you will have one wallet, I can have one wallet, and the third person can have wallet. And the transaction will be of the money that from the wallet to wallet. Contract can also have the account, that will be the program. So one is the contract account, that is the program one. One can be the person account, that is the wallet. So how do we do the transfer? We do the transfer using the transfer function. We use the transfer using the send function, and one more function, that is the call function. So here, using the transfer function, we can do the transfer of the Ethereum or Ether unit. We can use the send function. Means here we are talking about the money. We are doing the transactions. So when we are doing the transaction, there are some different functions. One is a transfer, one is a send function, one is the call function. So transfer function is most recommended because it is having the exception handling capacity. Send function do not have the exception handling capacity. We can do it with some more functions. And one more is the call function. That is least recommended because this is vulnerable to the contract. So there are three types of functions. One is a transfer function. Let me see here. So transfer function, this particular function method is having the gas limit as 2300, and it is the most secure function, we can say. It saves us from all the attacks. Transfer function, it throw the exception. As we know, just we can see the exception. Means if the transaction is not successful, it will give us the error. But while in this case, if the transaction is not successful, then also it will not give the error. So what we want is, we want the actual thing. So if the transaction is false, then we should get the exception. So the difference between the transfer and send is the exception one. In the case of transfer, we will get the exception. It will throw the exception if there is an unsuccessful transfer. But while in the case of send, it will not throw the exception, even the transfer is the unsuccessful. So in order to have the exception, what we require is, we require the require function. So here we have one more is call. Call is one more function, but here the difference is, we do not have the limit of 2300 gas. Means we can apply the gas here. Here we are applying the 20,000 ether, sorry, 20,000 units of gas. But while in the previous one, there is a limitation of 2300 gas limit. Here also 2300 gas limit. So this one is least recommended, but in case you need more gas, then only we will be using the call function. So there are three functions for the transactions: transfer function, send function, and send and call. Transfer, send, and call. Transfer, send, and call. All three functions to send the money, to transfer the money, to transfer the ether. The difference is, transfer is very much fine, while the send is least because it will not throw the exception, while call is again the least recommended because it will not throw the exception, and it is vulnerable because it is having some of the limitations, vulnerability to the attacks. So here we have, let's we can try these functions in case if you want to try. So let me try the transaction function. We can have this, we can create the new contract, transfer function. I'm just creating a new contract. So simply how we do it, pragma solidity 0.7.0. Again, the contract, maybe the contract I'm giving here, transfer one. Sorry. Yeah, transfer. So here what I want to do is, we want to do the transfer. Yeah, one more thing is here, one keyword is used, we are using whenever we are working with the money. So there is one keyword, that is payable. Payable will be used with the any of the function. So whenever we are working with the transfer, where we are seeing the balance, we are transferring the money. So function will be having one keyword, there will be the payable keyword. So we will see how it is. So function, this is public function, and it is payable. Okay. So function will be payable. Except a state variable declaration. Okay, fine. Function. This is in the other version. Okay, it was accepted in that version. It's not accepting in this version. So anyways, we don't need it. So expected a state variable declaration. Okay, let me declare the state variable. There is not a problem. State variable. State variable, maybe can you int 256 a equal to 10. Fine. Actually, I wanted to include one more concept here, but let it be. I'll explain that. That is a fallback function actually. There is a one function that is the fallback function. I'll just tell you about this. As if you can see here, I have not given any name of the function. So that is the concept of the fallback function, which I wanted to tell you. This is here. So fallback function is a function that does not take any arguments, does not return anything. Also, it doesn't have any name. So the function without name is a fallback function. And generally, whenever we do some of the data transfer, whenever we use this ether transfer, that time we use this fallback. So fallback is one of the functions that does not take any argument, does not return anything. As currently as in the example, we can see. Let me convert into this. Okay. So this is a fallback function. It doesn't have any name. It doesn't have any return type. But if you have seen the previous function is having the name also. It is having some returns value as well. But this is the fallback function. It does not have any name, no function name. This is simply directly function, and it does not have the return type. This is the fallback function. Fallback function does not have the name and does not have the return. So now we are creating one more function to get the balance. Get val maybe, and this is here this public view. I'm just creating this to check the balance. Returns u in बोल दो सर चेक करवा लो फोन करके. So just to get the balance, and I'm just returning this balance to this particular balance of this particular address. So current address is, we can denote with this. So current address is having one balance. So okay. So this is one of the function I have created to get my own balance. Then what I can have is, I can see the balance. This is one contract. What I can do is, this is, let's give this name as Vikalp. This is the contract of the Vikalp. It is having one address and it will have one balance. So let's create another contract. Maybe contract is Sage. Sage, and maybe it is sending some money. So function I'm creating just to send money, and I'm using here this address add. This is public and payable. As I told you, the thing should be payable. So we are using one keyword here, that is payable. And now what we need is we are sending the money. So add dot transfer and some access dot value. Okay. So here what I'm doing is this, with this we are doing some transfer. To whom we will transfer, we need to pass one address. We will pass address to this function, and some money, whatever the amount we will give, that will transfer to this particular address. So this is the receiver and this is the sender. So if we see the execution, both are compiled, and if we see here the Sage, fine. So just to give this, I'm okay. Before this, I should have the receiver's address. So this is the receiver. I'm just deploying it. Okay. So receiver is having one of the address. If you get the balance, currently it is 0. So this is the address. Just I've copied the address. From this, we can copy the address. And I want to send the money. So from this Sage, I want to deploy. So this is another contract. So I want to send the money to this address. This is the address of whom? This is the address from the Vikalp. So Vikalp is having one address, and how much money you want to send? Maybe I want to send the 10 ether. So 10 ether value you want to send. Maybe I can give you this 10 ether and send money. So the transaction is reverted to the initial state. What is the problem? Okay, there is some exception. Let me give another one, the only 10 and transfer. By the server. Just a second. Send. See. Conversion reward the the function should be payable if you send the money. The function is already payable. If you send the money and the value should then be less than the current balance. Current balance is 0. Redeploy. So one address. This is address. And the other one. This is 10 and I'm doing this transfer. The message dot value is this only. What function is there? We have that send. Let me try with send. With send is it working fine? If we see the balance of this is 0. Okay. Again, it is also giving the exception, but it is not printing. This is what the difference. Like money is not sending in this case also, but it is not giving the exception, and the exception is given by the previous one. One second. This is payable. Maybe the receiver is not payable. Okay, sorry. This need to be payable. Fine. So this need to be payable. Let me try it, transfer again. clear the console and clear all the contracts. Once again, I try this. Deployed, fine. It is deployed. It is having the get balance as 0. I'm checking this address. Then the another one, Sage, deploy. It is deployed successfully. Okay. Take the address. Vikalp I have taken already. Given this 10 week. Okay. And send money. Fine. So now the transfer is done. This is, you can see here, it has transferred from one address to another address. We have done the send money, and let's see the balance of this here. So here, if you can see here, there is a 10 week. So this is how the transfer is done. So the payable is required here. Payable, hope you understand the concept of the payable here. So whenever we have the payable, then only the transaction will occur. I hope this is clear. And instead of transfer, we can use the send the similar way. This will also do the same. The only difference is you have observed we had the send, there was no exception. When you are using the send, there will be no exception. So in order to remove it, you need to use a require and the current balance Sage function. We'll run it as just now I removed it. So here the Vikalp, once again I'm deploying it. Clear it. Clear once again. So once again I'm deploying this Vikalp, and we can see here the Vikalp does not have any balance. I'm just copying this address and I'm deploying the another Sage also. Sage is having one address, so it will have the money. We can try this. We can get this address dot balance. Then probably we can get the balance of the Sage. Currently, it's not showing the Sage balance, but we can print it using this particular variable. So currently, what we can see is we can see this one. Having this, then it's this. Okay, it is transferred successful, and if you see on this, so I'm getting the 1 Ether in the V is a unit, so that's why I'm getting this money of 0. Probably it is 17 zeros. So this is working fine. Sage will have one balance. We can try this. Again, we need to return. Let me try to return this. Already having one. No. We can try that function. This one. Once you try it out, you can get the balance of Sage. So here we have the function. This is send. Previously, just now we have used the transfer also. And similarly, we have the call, but call is not recommended. So if you can see the screen the similar way, you can use the call also. And in the call, you need to pass some gas and the Ether value also. Ether value also you can pass. So this is how the call will work, and call does not have the limitation of the gas. We can use the gas more than 2300. Okay. So this is how like we have the different function. If you observe, like to transfer the money, to do some programming, and to do some fundamentals of the Solidity. So just a recommend, just once you people check these examples and try to run these programs. These are very basic programs which can be run, and we can understand the concept of the blockchain. So hopefully it is understood, because we have used very small programs only. So once try to execute them to more understand about the Solidity. So similarly, like Solidity is having very limited means concepts. So hopefully it will work. So that's all for the day. Tomorrow again we will continue with some more internal concepts, probably how we can use it. Analyze the balance of Sage, we can do transaction with the finish line. Sage will also have one of the by default it will also have some ethers. I have not initialized, as currently we are not working with the real one. So it is, if there is a contract here, then it will have one balance 100 ether kind of. We have not initialized, as in this Vikalp also we have not initialized. So every address, currently we got some addresses. So every addresses are having some of the values and some of the ethers. So that's what we are using. We are not initializing. Okay. Yeah. Currently we got some addresses, no? From this accounts, we have got some addresses. Probably it is using from this. So I hope this session is useful and for the programming point of view. So once just try to execute them. That's all for the day. Any of the query you have, you can ask me on the WhatsApp also and this session also. Okay. So thank you so much for all the participants. Tomorrow again we will continue.